So with this, let's move on to another component of enzymes, whereby we'll be looking at what is the induced fit model. Okay, now just now earlier on we talked about what is the lock and key hypothesis, in which that the lock is the enzyme and the key is the substrate, and that there is only one enzyme for one substrate. Okay, so this was the general line of thinking for a period of time, until scientists they realized that we have got too many substrates in the body itself. However, the number of enzymes that are discovered or known doesn't match the total number of the substrates if it was to adhere by 1:1, which means one enzyme is to one substrate. Okay, so later on, research, what it shows was that an induced fit model was more likely for these enzymes. Okay. So the induced fit model, as the name suggests, is that when the substrate enters or nears to the active site of the enzyme. Okay, so this is the enzyme, this is my substrate. So as my substrate enters or nears the active site of the enzyme, there will be slight induced bonding, and this slight induced bonding causes a conformational change. So which means to say that my active site actually conforms to fit my substrate into it, therefore allowing an enzyme substrate to be formed. Okay, so of course in this scenario we cannot have a huge drastic difference between the type of active site and the type of my substrate itself. You can see that the grooves are still similar in shape. It is just the orientation that changed slightly in order for my enzyme to fit into my substrate. Okay, so using this line of thinking of the induced fit model, it better explains how we have a limited number or type of enzymes in the body that is able to accommodate so many different types of substrates.